Hi guys, and welcome back. It's now 2021, and I hope you guys had a good Christmas and a happy New Year. Here in the UK, we had some bad news yesterday. We have now gone into another national lockdown, which is fun. We have to stay at home, and we have to homeschool the kids, so that's going to prove to be interesting. So today, I want to go over something. We're going to cut that out. Okay, yeah, we're going to cut that out. Yeah, so today I'd like to continue with a couple of the unit tests. I've done a little more work on the dependency injection. I have StructureMap scanning the assemblies, which is nice. We'll talk a little bit about that, how that was implemented, and also how to unit test that whole process. And then we'll talk a little bit about the database, how it communicates, and how we're going to use it combined with the repository pattern and using some caching as well. So we'll jump right in. So I'll just grab my notes here on the database stuff for a bit later. So last time I did the mapping tests, and we have this, covers some bits on unit testing, one-time setups, and things like that. Okay, so back to the IOC. Now, what's nice about the IOC container, the library, is what it can do is you can create services and classes that implement your interfaces, and then go and tell the tell StructureMap to say, "Hi, I'd like to actually go and I'd like you to go and find those things." So what we'll do is we'll actually show that happening. So in this is my no, wrong one. Where's my test? Okay, here we go. So this is my test class for the dependency injection. So we wrote this utility class, and this is our container, and we added things we can do. We can get the instance of things. We can register the provider. We can get the same register provider, and we discussed that a little bit. And I believe I did something in here that I can't remember. Okay, right. So we need, coming back to the test, we want to be able to test that. And what we need to test that is we need to create an interface that is going to have a service that's that's going to implement it. So what I did here is I just created a simple, real simple interface that has a function, and that function is going to return true. Yes, we're going to get something. The reason it should return true because by default, C# initializes variables to the default values. So in case of a Boolean, that is going to be false. Things like ints are 0, and objects are null and stuff like that. So this is what we'll have. And then we have our service here that implements this test service interface, and we implement our function, and in our function we're just going to return true. That's great. Right. So we have this one-time setup here, and what we want to do is remember, this is a like a singleton. We have to create an instance of this, and in the constructor of that startup section, it goes and gets everything ready. And so we're just going to say, right, for this one-time setup, we just want a new instance of the IOC. And then our test is that we should be implemented. And so what we're going to do here is we're going to get the implementation. We're going to say, hey, I want an implementation of this particular this particular interface. I'm going to make sure that interface is not null, because if it is, something went wrong. And we're going to make sure that the return of this is in fact true. In here is a little bit of debug help. What this does is it goes through, there's a function on StructureMap that allows you to say, go and get me what you have. Go and show me what you have. So we're going to we're going to make a call to this. This won't come out in the test, but we'll see it inside our output, which will be quite nice. So to do the scanning. Now, as we know, we have this library here. And this library implements our IOC container. Our dependency injection, our inversion of control, all of this jazz is going to mainly happen in here. And before, we didn't have this. We just said, go and do your thing. And then we were able to go and add things into here called register provider, where we say, right, we're going to implement a service. And we did do that. We did do that in the mapping test. So yeah, here we are. We said register provider. So in this case, we want the mapping service, and it's going to be implemented by our test mapping service here. And inside here, I was also debugging around, but we don't need that in there. We can run these tests. We can run those, and they should work. Am I running? I am running something. Don't know what I was running there. But here we have our test explorer. We have our mapping tests. It's picked up the IOC scanning tests here. And if I run those tests, they should build because we changed the code. And it should run, and it should run those tests, and they should come back as being, yep, we're all good. Yep, they're all good. We can see here and how long they took. 7 milliseconds. All right, so these are the tests that we want to have. We want to be saying, we should get our interface that should be implemented. But as you notice here, I've actually registered provider for the mapping. Inside here, I have not. So this is going to use the new scanning functionality that StructureMap has. So if we go into the implementation of IOC, we can say inside our lazy container, and so when we create this, we have a container. This is just a syntactic sugar to basically say, I don't really want to call it anything. You could call it X, you could call it container, you could call it C, whatever. But actually the important thing is we're going to scan. Now, my solution is I have the IOC stuff in this project, and then everything links to that. So inside the output of this, you're going to have your program executable, and then you're going to have a bunch of libraries and assemblies that executable depends on, including the core.inversion of control, including things like Microsoft.system, various dependencies that we have here, and they are things like the frameworks. We're going to have the Microsoft.NET runtime. We're going to have system stuff, and we're also going to have NUnit as well, because we're going to be using the unit tests. And this allows me to say don't load those. So what this does is says, right, okay, good. So let's get the executing assembly, in which case it's going to be the unit tests, and we're going to say go get me the file path to that, and we're going to take the location of that, and that's going to give us a string which says this is the file path, and then we're going to go to the StructureMap graph assembly scanner, go and load any assemblies in this path, and then for each of those, what we're going to do is we're going to, if they conform to this check. So if there's anything called Microsoft, anything that begins with Microsoft dot NUnit system dot, we don't want those, because otherwise we just end up with this huge graph of 150 whatever assemblies and services that we're not necessarily going to use. The calling assembly, so there's some conventions, some helper functions that StructureMap allows you to have. So the calling assembly says really anything that is the assembly calls we want to know about. This is another convention. This basically says load any service, load any class. Sorry, it doesn't do that. What it does is it says it looks through all the interfaces and then says, right, go and look at any class that implements those services. And if you find a class that only implements that service, and there are no other classes that implement that service, then go and add that relationship. So if you have, say, an interface called test service, and you have a class called test service, and that test service class is the only class that implements iTestService, then the scanner will say, right, when someone wants an give them, spin up an object of test service, give them that. That's what that means. The default conventions basically mean that if you have something called let's have a look. We might have something called IHTTP client. If I could spell. Yeah, that might be our interface. We might call it that. And then if we have a class called HTTP client, now the client could implement HTTP client. Let's see if I could spell again. But it might implement something else. It might implement a data reader or something else. Yeah, it might implement all of this stuff. But because we have an iHTTP client and we have a class called HTTP client, it's going to go, for this interface, we're going to use this class. And this is what the default conventions are. So what that is going to do is that is going to go, when we create this container, it's going to go and scan those assemblies. And we see that here. This basically spins up. We could step through it, but essentially what we want is we want this. What I can do is we can see that running. If we run that, and I suspect we could step through it. Okay, we didn't have that. I'd say, well, let's debug that. We put a breakpoint there, and we go debug test. And you'll see it now. Okay, here we go. So let's just grab our output window so you guys can see it. Gonna come here, and we're gonna do this. And here we go. And it says all scanners. Scanner 1 assemblies. Scanned automapper core.data.mapping. So it's picked up mapping, picked up a version of control. It's got Newtonsoft, StructureMap, test host, unit test, utils.core. Okay. Unit tests contains the implementation of iTestService. This is where it is implemented. It is implemented right here. So then we can say, go get me that implementation. We have that implementation, unit test.ifc.scanning test.ifc, exactly where we thought it was going to be. And let's implement, let's go and execute it. And yeah, so that is the scanning. Now that's really useful because what that allows you to do is now you can write code, you can write interfaces inside the database, for example, and it will automatically get picked up by the scanner, and it will automatically get added to the container, and then you can start building things correctly. Like, I mean, we can now use, we can use dependency injection, for real. We can create a repository. We can say, I'm going to have a database repository. We can say, get me an instance of the database repository. And if the implementation of that still requires other interfaces that we have created, the dependency injection system, the StructureMap, will know how to create them because it scanned them, picks them up, it will spin those up, it will hand them all over, and we will get a fully working database repository. Which nicely segues into the database repository of what I would actually like to do. So let's have a little bit of a drawing. Okay, sorry about that. User error. Okay, so we're going to have a database here. This is our database, and we're going to want stuff to talk to it. DB. Right. what we want to have is we're going to have, the goal of this is to create a system that is, on the one hand, it's kind of agnostic a little bit, where you're basically going to say, I'm going to specify a table, and it's going to be some CRUD operations on that table, and we're going to do things like listing, getting, updating, deleting, and we don't really, we're going to leave the specific implementation of that to a more specialized class that we're going to use. So we're going to have some table objects down here, and these objects are going to be things like our users, our inventory. These are essentially our data types, and what we want to have is we're going to have something that is going to do, we're going to have some kind of repository, but it's going to be for a particular table. So that's going to be our specific implementation for that. We're going to then have our service, which is our iRepo service. We're also going to say, okay, what we want to have is here, whenever we read from the database, we want to be able to put that in our some sort of cached repository, and that's going to implement an interface as well. And so the idea is the user, us, we're over here, we're going to say, I want to read from a particular table, and it's going to go, okay, well, we're going to pull this, we're going to go through here, which is then going to pull that there, from data from there. And then as part of that, we're also going to say, we're going to load it into the cached repository, and then we're going to return it to us. Now the next time round, we're going to say, right, I want to read again, and we're just going to go to the implementation. And this time what we're going to do is we're going to say, does this item exist in the cached data? And we're going to say, yes, it does. So then we just return it. If we do an update, I'll do the update in red. If we're going to say we're going to update our data, obviously we're going to go through the implementation. We're going to say, let's check, do we have it? Do we have this cache thing? Do we have this thing in cache? Yes, we do. Pull it out of the cache, do the update, write it out to the database, and then resave it into the cache. The delete will basically do the same thing, but in this case, we're going to delete it from here, and then we're going to also delete it from here. Now, what we can do is we can think about having a a thread that we just, I just do this as a thread here. It's something that just essentially keeps on running forever. And what this can do is, in the deletion process, we can do a soft delete. We don't do a physical delete on the table. We mark that record for deletion, and then at some point we can say, get all the records, get all the records. Are there anything that need deleting? Or we can just execute a store procedure that says, right, go and purge all of those records from each of the tables that are marked for delete. And this allows us to do things. This allows us to reduce load on the database, and it gives us more performance options later on down the line. Because obviously, if we're just, if the player moves, then what we can do is we can essentially batch. We can do other things as well. So, for example, the updates here. yeah, what we can do is we can batch all of those up inside the cache repository with a needs to be saved to the database. So the thing is that, when you're updating a record, as long as you save it somewhere, if you're in the if you update the cache data and the next time you read, you return from the cache data, you are essentially reading the most up-to-date version of the record, which is great. And then what you can do is you can say, okay, every minute or so, are there any outstanding records from in the cache that need to be updated to the database? Yes, there are. Great. Go and batch save those. You could do a merge operation depending on the amount of data that you're doing. And that, you can do, so instead of just doing an update where an ID is, you can create a data table and you can do, load in these 100 records. You can have thresholds as well. So you could say, on program, shutdown, then we can batch save all these updated records to the database. We can have that, once a minute or so. We can say, hey, only update if there's 100 records that need updating. We can mark things, potentially we can mark tables with annotations that say that this table can't be cached. So say, no, okay, we will always have to go to the database. We can use reflection to pull off those attributes, which would be pretty interesting. And we can do things like, for example, these, you could say things like this table can't cache updates. It could be read and stored in the cache, but any update to those records has to be written directly to the database because they're important. You might say player position, or server set, program settings and things like that. Blocked IP addresses and so forth. So that's what we're going to start to do. We're going to start to work on that, which will be interesting. I have no idea what that was. And we're going to put that inside, obviously, our database. So this is our data. This is our database. This is our DB thing as well. I know this is taking a bit of a way to get to there of actually talking about what code that we want to do, but there is actually a step that I'm missing, and that is we need to add some configuration as part of that process, because we need to know where we're going to save the database. What are we going to use? Decided I'm still going to use Dapper for our ORM because I think it's nice to present an alternative to Entity Framework. Entity Framework is used everywhere, but there are others out there, and I think it's always good for people to see what other people are using. I've been watching some other coding things for work, for work-related stuff, and that uses Entity Framework. And so I have more of an understanding of how you set the connection string in a DB context, which is something that I had struggled with in the previous version of .NET Core to do. But we'll still be using Dapper because Dapper is slightly more performant than Entity Framework because it's simpler. It's not as it doesn't have all the features of Entity Framework. I'm still going to stick with StructureMap because I think that's nice to show other people how that's using. The next step will be the configuration, and that will be basically reading from the settings, and we will do some encryption as well. So if the settings ever leaked out, they're encrypted, and so you can't find the database connection information. So I'm going to leave it for that. Leave it there for today, and I will set up the configuration, and I'll encrypt that stuff. I'll show you how to do the decrypt. But yeah, thanks for watching, and take care.